to introduce the speaker, Mas Ahmad Mardiansyah. He is a co-founder of GLC Networks. He is also a trainer, mentor, and consultant for an IT and ISP as well. So, Mas Ahmad, are you ready?
Yeah, sure.
Okay, now we will begin, and I will turn it over to you, Mas Ahmad. Thank you and enjoy the webinar.
Thank you, moderators. Okay, for guys, before we start, I need you to turn off your camera. Thank you very much. Please, I have to force you to shut down your video. Really sorry about that. Right. Okay, so welcome to GLC webinar. Today we'll be talking about running BGP with Mikrotik. Okay, before we start, I just want to make sure everyone can see my slide here. Can you see? If you can, and then you can reply on a group chat. All right, can you see my slide? Can you see the slide?
Yes,
Okay,
I can see the slide. Thank you.
Okay, thank you very much for the confirmation. Okay, so we have 49 participants. Oh, okay, now it's 50. Okay, it's quite a lot. Thank you very much for coming. And I can see some of you, or even many, are not from here, not from Indonesia. Okay, we'll be speaking in English as usual. No worries about that. Okay, let's get started. So these are the agenda topics, subtopics that will be discussed in our webinar today. This evening, wonderful evening here, not so humid, not so cold, not raining today yet. It's raining season here in Indonesia, also maybe in Southeast Asia, but today, I mean, at this time it's not. So thanks for that. We'll be talking about, we start the discussion about introduction, and then we discuss about the internet things, how internet really works, before we get into the details about the BGP. Okay. And then if time permits, we're going to have a live practice for the BGP. I'll be preparing the username and password, also the topology, so that you can log in and then check your Mikrotik there. Right. Okay. About the GLC, it's organizations in Indonesia. We're based in Bandung. Our areas are training and IT consulting. We are certified partner for Mikrotik Ubiquity, Linux. We also have a product called Radius Manager, GLC Radius. We develop ourselves, and then in this Radius, we also include some functions like automation, billing, and then other stuff like CRM, customer relationship management. We also have a regular event like what we have here today. Every 1 week on Thursday night, we have a webinar. About myself, my name is Achmad Mardiansyah. Okay, I'll be turning on my camera here. If you can see, okay, that's me. Yeah, good evening, everyone. Okay, just want to say hi to all of you. And I'm based here in Bandung. I'm Linux user since 1999. First time using Mikrotik 2007, Ubiquity, and then other brands of networking vendors like Cisco and yeah, other vendors. I'm a certified trainer as well for Mikrotik. We do routing engineer, internet networking, MTCINA, traffic control, IPv6, wireless, also layer 2, like switches and bridge. Wireless is also layer 2, right? We also do Linux and development. If you have a LinkedIn account, we can have a connection there. Okay, that's my LinkedIn account. Okay. What's next? Okay, yeah. About past experience, this year we had a project in Congo and Malaysia regarding network automation and IoT integration. Last year we had a project in Congo. We built ISP from ground up, from nothing to something. It was a wireless. Yeah, it's a little bit painful because lots of connection there, lots of interference. But yeah, as long as the connections is okay, everyone is happy, and then we are happy too. And then a year before, we had a similar projects for related to ISP or networking, like a network revamp. We need to optimize the current network, doing planning, integration with the radius, yeah, and so on and so forth. Migration from bridge network to routed network. So we need to do network planning for that. About the webinar itself, it's a regular event every Thursday night. Okay. If you have a topic, and then it is really recommend if you share to us. If you if you have a topic that needs to be discussed, feel free to share your topic here in the group chat. Okay. We'll discuss, and then we'll put a schedule of your topic. So there are several topics already lined up. You can check it in our schedule. And yeah, if you have a topic that needs that you want us to discuss, and then feel free to share it to us. Okay, about yourself, I can see some of you. Oh, sir, please turn your microphone volume up. Okay, can everyone hear my voice? Because I can see here somebody is not listening to me clearly. 10 out of 10. Okay, thank you very much. So perhaps you have problem with your speaker over in your place. Okay, 10 out of 10. Right, all good. Right. Right, thank you for confirmation. So at least I know that I'm speaking well in terms of volume. And then thank you very much for introducing yourself. I can see some of you are from, I don't know, yeah, from Nepal, okay, from Bangladesh. I think you're the same person that also attend the webinar, previous webinar, yes. Thank you very much for coming again. Right, really welcome. Okay, from some of you are from Philippines, another person from Bangladesh. Thank you very much. I can see some are from Africa here. Anyone from, oh, Bulgaria? Wow, that's far.
And you, Papua New Guinea also.
Oh, Papua New Guinea. Oh, right.
Yeah.
Oh, Malaysia, Philippines. Wow. Yeah, from Sulawesi. Okay. Oh, I was in Bulgaria around 10 years ago. At the time, I was assigned in MTEL, Bulgaria. I was doing telecommunication things over there. Yeah, not long, only a few months. Yeah, it was good. And then it was very cold because I arrived in October and then returned in December or January. I forgot. It was very cold. Yeah. Wow. It was snowing, but it's cool. Yeah. Okay. Let's.
Oh, anything else from Central Africa and Albania as well.
All right. Yeah. Thank you.
Welcome.
Thank you very much. Yeah. Now they are bought by A1 from Austrian Telecom. Oh, okay. Nice to hear that. Okay. Thank you, people from Africa. But your name is Huawei. Yeah. Okay. I hope everyone is uh, enjoying the time, even though it's not great because of pandemic. But yeah, we try to enjoy our life as much as possible. Right. Okay. Let's get started. We'll be talking about how internet works and then started with some history. So before we enjoy our current internet, the internet actually was a research project done by DARPA, the United States, in the United States. At that time, it was a Cold War era. So at the time, they want to create a communication where it has a capability to reroute a message from one place to the other place, uh, for example, automatically. Okay, so that's why they come up with an idea about, okay, we need to have an addressing, we need to have a routing. Okay, so if this link is not available due to any reason, like for example, nuclear bomb or sabotage or whatever. So the packet is still be able to deliver through other routes. Okay, because at the time there was a telecommunication network. Okay, I said telecommunication. Okay, and it was really manual, so you have to route, and then it was an analog communication. Yeah, so from A to B, we have to go through, we have to go to have a connection through this, a series of switches. Okay, right. So that was it. And then before Ethernet, and I mean Internet, there was a computer network. Okay, but unfortunately, uh, those networks are really vendor dependent. Okay, IBM only be able to talk to IBM, Apple with Apple, digital and with digital. So it's very closed source. It's not open, very proprietary. Okay, so one vendor only talk to the same vendor, which is not good, right? So what we do, we need to set up a standard for communications. In this case, we set up the internet, and then in this internet, we set up a standard, and that includes the standard for message transfer, okay, and then the application itself. So it doesn't matter your operating system or the hardware. For example, here is digital, here's the IBM, doesn't matter. Okay, doesn't matter. As long as we are talking in the same protocol, in this case TCP/IP, and then this protocol is very popular, really wide adopted, and then we are able to talk like what we are doing now. Okay, including this webinar, right? We are having a communication based on the internet, and the internet is based on TCP and IP protocol. Okay. Right. Okay, look, if you have any questions, can you just type in the group chat, okay? We have 67 participants. Well done. So after the internet, we already have a unified protocol. So that's why we are able to talk to any vendor, okay? Because all vendors talk in the same language. So basically a protocol is a language of communication. So internet is open, lightweight, global, it's uniform end-to-end and has to be neutral, okay? Also, we set up a series of layers and then each layer um, responsible for a functions, okay? For example, a physical layers, it determines how we send the signal, electrical signal, and then we have another layer that's responsible for other functions. Okay, why do we split those functions into layers? In order to accelerate the innovations and then also interoperability. Okay, so that if one layer has a problem, it will not affect other layers. In traditional communication, we have our own physical network, like we have a network for voice, data, and then TV, and then others. Now, everything is we call it uh, converge into one single network, which is the internet. So everything will be glued by the internet. Okay, because internet has the unified protocol. Yeah, either it's a TCP, actually TCP or UDP, right? So for real time, we use UDP. And then below we have a IP layer. So there's only two layers. We refer to a 7OC layer. TCP is layer 4, and then IP is layer 3. Okay. So everything that unite us is these two layers, layer 3 and 4. Okay. Okay, so previously I said standards. We need a standard to set up a communication, a standard communication. If you don't have standard, and then we cannot communicate, right? I speak Indonesian, you speak in your local language, and then we cannot talk. We cannot exchange idea. Okay, so we need standards. Like the language that I'm using now, I'm using English, and then I hope that you can understand English as well, right? Yeah, that's standard. And then we follow the standard, and then we can have a communication, we can exchange idea, we can do many things because we already have standards, we can do communication. One things that is determined in the protocol is the addressing. Okay, so as you know, in the layer 3 we have internet protocol layer or IP, and then there is an international body that regulates the IP addressing. It's called IANA. Okay, right. So IANA. So this is IANA. IANA is the big boss. Okay, Internet Assigned Number Authority, and then one of the functions is to regulate IP addressing and other things as well, such as domain. But IANA delegates to RIR. Okay. Here in Indonesia, we are under APNIC, so this is APNIC here. Okay. For Africa, you have AFRINIC, and then Europe is RIPE NCC. In Latin America, you have LACNIC. Okay. In North America, you have ARIN, right? Yeah. So if you want to connect to the internet, every organization must have an IP address block. Okay. How do you get that IP address block? You talk to RIR here. Okay, so if you want to join an internet, if you want to be a part of internet, you have to use the IP address. Okay, but I never talked to IPNIC. What the hell is IPNIC? I never talked to them, but I can connect to the internet. It means that your ISP is doing that for you. Okay, so this is how it looks like. So you have a network. This is how the internet topology, not the real one, but you get the idea. This is how the network looks like. Okay, so basically internet is interconnected network. Okay, internet, right? So you have a network, you have a network, you have a network, lots of them. And then every network must have an IP addressing, right? So for example, this one belongs to this one belongs to that, this one belongs to this one belongs to that. Okay, I assume you already know the IP addressing, okay? If not, then you are in trouble. Okay. So I assume you already know the IP addressing. Okay. So what's the hell is 60.100.0/20? What's that mean? What's that mean 20 here? It's called prefix. Okay. And then you have to do a subnet mask calculation for that to determine how big is your network. Okay, I assume you already know that, so I don't want to spend time discussing that, right? So if you don't understand, Google it. Right, so let's continue. So every organization must have an IP address block, and then you get IP address block from RIR. So this is you, okay? So you are subscribing a internet connection from your provider, from your ISP, and this is you, a small dot in the internet. So here you are, okay? Just small dot. Or maybe here, make it here, and then you connect to your ISP, okay? So, but you never talk to the APNIC before. You just heard it, okay? So who is doing that? Your ISP here doing that for you. So your ISP must apply for a public IP address, and then they must be identified as AS number. Okay. So every organization must have an AS number, must have an IP address block. Okay. Google must have, Facebook, other ISP, you name it. Cisco, Mikrotik, whatever. Okay, so if you want to be part of the internet, so actually you're not connected to the internet, you are just part of the internet. Okay, and then how can you use that IP address block? The ISP will assign the IP address to your device. How can they do that? Well, many ways. They can use DHCP, they can use PPP, they can use a static assignment or any other any other methods. Okay, they can set up a tunnel, for example. That can be used for IP addressing, no problem. Right, so at least up to this point, you get an idea how you get connected to the internet. So this is, oh, okay. So this is how the connection looks like in your ISP. Okay, so this is you. Okay, you are a customer here. Okay, and then this is your modem. This is your laptop. This is your phone. Okay, and then this is your TV. Whatever. Okay, this is the router actually, and then the router connects to the uh, uh, ISP, and then from the ISP it's usually layer 2 connected to the router, and then there your ISP have a border router connect to the other ISP. So if you see it from the helicopter view, usually it looks like this. So this is the customer connect to this, and then this connected to that, that connected to others, others connected to others. Okay, so it looks like a star. Okay, so usually we called here, the one that connect to the customer is called access network, and the one that is, because the one that one is located in the middle, we usually call it is core network. Core network. Okay, so that's the difference between access network and core network, right? And then here we are. Go to Bordergate Protocols (BGP). So BGP features. So previously we already know that your IC must have a border router, and then this border router connects to other organizations. Okay, so and then this border router must run BGP. Okay, it's not clear. Okay, I'll write again BGP here. Okay, so BGP is currently is the de facto protocol that can carry the internet. Okay, internet protocol. I mean the whole routing prefix for the whole internet. Okay, so by connected to BGP, by having a BGP connections, you will get a whole prefix from all over the world. Okay, so it's very big. When I first time configured the BGP, the total prefix is around 400 something, 400,000, 400,000, yes, 400, almost 500, yes. So 500,000, okay, almost 500,000. And now I think it's more than 600,000 plus, maybe almost 700,000. Okay, so that means more and more networks are created every day, or maybe. Okay, so it means that the networks have become larger and larger. Many organizations are wants to be part of the internet. Okay, next. Oh, next. Oops. Okay, so these are the BGP features. So it is path vector protocols. It has incremental updates. It has option for policy enforcement, VLSM, CIDR, widely used for internet backbones, connect autonomous systems. So the main function for BGP is to carry the routing tables between AS, okay? And then inside AS, we have lots of routers, and then those routers are running BGP. So first, what is VLSM? VLSM is variable length subnet mask. So that means we can divide an IP address block into subnet masks. So before we have VLSM, we have a classful IP address, okay? Classful IP address, okay? So that was done many years ago in the beginning of 1990s, okay? They have a classful IP address. But now they have classless IP address. So please do not say class A, class B, class C. It's already obsolete, okay? Because we use VLSM now, okay? If you say how big is your network, oh, I'm class A, oh, I'm class B. What the hell is that, right? So VLSM, we already have RFC here that discuss about the VLSM. Okay, it was released in 1995, long time ago. Hey, dude. So next time when somebody asks you how big is your network, you ask with the subnet. Oh, sorry. I mean with the slash, with the prefix. Okay, is it /16 or /25 or /20 or whatever? Okay. Okay, guys. Sorry. It was there was a pause a bit. So VLSM is a feature. So because previously people who designed the internet were very generous. They don't expect the internet become so big like this. So in the beginning, they have a class A, class B, class C. Class A automatically is /8. Class B is /16. Class C is /24. That's all. It's very, very simple at the time, okay? But it's not enough. If we follow this rule, the IP address will already round out in the beginning of 1990s. Okay. So we don't use VLSM, okay? And then here's the RFC, okay? Request for comments. So basically it's a request for, because internet is run by community, and then you can write for your RFC to improve the current policy of the internet. Okay, and then somebody wrote this VLSM, so please do not use /8/16/28 because there are lots of ways thing of IP address. Okay, so better if we just use VLSM, and because we use VLSM, we are able to use CIDR. So VLSM is the idea of using the variable subnet mask identified by prefix, but CIDR is more to the routing. Okay, so with the CIDR, we do routing based on the classless here. Okay, so classless routing. So in the beginning, in 1990s, the routers only route /8/16/24. Okay, at the time. But because of VLSM, and then you can see lots of /16, for example, /17, /21, /19, whatever. Okay, those are possible because of VLSM. Anything else? No. So this is CIDR. Okay, was done in 1993. See, long time ago, man. See, and but I still see somebody is, oh, I'm class A, I'm class B, I'm class C. Come on, man. We don't use that term anymore. Okay, so as you can see here, I can see this is /24, this is /13, right? This is 17, 19, 18. So which one is class A, class B? No one. See, please do not say CIDR anymore. I mean, classful anymore. Okay. We use VLSM. Okay, there is no class A, class B, class C. See, right? So please. BGP is path factor protocols, as it's mentioned as one of its feature. Okay, so this is one of BGP routing. This is BGP entry. As you can see, this is the routing entry, and then this is the gateway. Just for example, and then this is the gateway status, and then this is the AS path. Okay, so number here is showing you the path of the AS to go to this destination. Okay, so first we go to here, and then here, and then here, 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 and then finally we arrive here. All right, so that's how BGP works. How many routes? How many routers? I don't know. But how many AS? Oh, we can check it here. 1, 2, 3, 4, 5, 6. So to go to this destination, we have 6 AS. All right. Yeah, so this is one example. Okay. So this is you. You connect to here, to here, to here, and then to destination. Okay, so inside this, oh, okay, this one is using red. Use other color. Okay, let's use maybe green. Yeah. Okay, so we have AS here, another AS here, AS, AS. Okay. It doesn't mean that one AS only consists of one router. No, it's not. Okay, so inside AS we have that can be so many routers. Okay, so this is just a simplification about the how AS looks like. Okay, and then when we do a BGP, we need to set up a peer. So it's not like OSPF where we can automatically detect our own peer. Okay, BGP is not, because it's between AS number. Okay, so this AS number and this AS number is different, owned by a different company. You cannot just automatically set up like that. Okay, so what you need is to set up a peer. Okay, you have a AS number here, you have another AS number there, and then you set up a peer. Okay. So about the peering itself, we have several types. Okay, so you have a transit, you have a peering, okay, or you have a default. Okay, default means you can you just connect to the one, just connect to one AS. Okay, so it's similar to, I mean, the connection that you are having now. You just only have one connection, right? Yeah, if the connection down, and then you're dead because you just only have one upstream connection. But if you have peering, if you have a transit, especially if you have multiple transit or peering, you can have a sort of redundancy for that. Okay. Oh, okay, I can see a chat here. Hello, Indonesia. This is ADBC from Nigeria. Okay, hello, welcome. Let's continue. I think it's daytime in Nigeria right now, or maybe 12 o'clock, 1 o'clock, lunchtime. Okay, so this is how it looks like, right? So we have usually in every in in every country usually, or every city, they usually have a place called IXP, Internet Exchange Point, where all ISP or AS number connected to the, okay, so Internet Exchange Point is the place where AS number are met. Okay, basically it's just a one big router and then a big switch, and then everyone can do a peering to each other. So if they are connected to here directly, it's called peering. Okay, so if you have a provider A contact the provider E, but it's not direct, you have to go through provider C here. Usually it's called transit. So provider C is providing you a service to connect to other AS because you don't have direct connection to them. Okay, and then usually this one costs money. You have a price. Yeah, so it's similar to, yeah, I mean, it's similar to what you are doing now, right? Uh, yeah. Uh, yeah, you connect to an ISP, okay, and then the ISP is providing a transit for you, okay. Yeah, so they, because you don't have, for example, you want to access Google, right? How do you access Google? You go through your own ISP, okay. So that ISP provide a transit service for you to connect to the Google, okay. But you don't want to pay anything. How? Okay, you go to Google headquarters, you connect your laptop, and then you don't have to pay because you have a direct connection to the Google, right? You go to Google data center and then set up a peering, and then okay, here Google, I connect to you directly if the Google wants. If not, and then you cannot do that. Okay, because to have a direct peering with Google, there are several stuff you need to provide to them. Okay. Yeah, usually they want to have a face-to-face meeting with all peers that connect to them directly. Right. So, okay, I have a question. Can you explain more about IP transit? Yeah, that's IP transit. So IP transit is a service by a provider, yeah, that provides a connectivity to go to other AS. Okay. For example, to Google. Okay, everyone here loves Google, right? Everyone who use Android must have a Google account. Yes, you have to connect to Google server. So by doing so, you must have you must connect to Google IP address. Do you have a direct pairing to Google? No, right? So you have to go through other ISP that connects to Google. So that means that ISP will provide a IP transit for you. Okay, so that's the IP transit. Actually, the transit is just like that. Why do people make the IP transit is so complicated definitions? So transit is just a transit. I mean, as the name suggests, right? Just transit. Okay, because they're allowing their own network for your own bandwidth. So your traffic can go through their network. This is the autonomous system, okay, the collection of network with the same routing policy. That's the definition of AS number identified by a number. Okay, AS number can be, no, I mean, AS system can be, it can be a single ownership, okay, can be multiple ownership, okay. And then we have BGP Basics here, okay, so basically you have AS number, okay, and then this AS number you connect to, you set up a peering to other router from other AS number. Okay, and this is the forwarding table. I mean generic forwarding table process for BGP. So you have incoming prefix here. Yeah, so you have incoming prefix, and then it's received by BGP, and then you must have a filter here, right? Sometimes you reject the prefix, sometimes you're not, and then it becomes BGP tables, okay, and then becomes a routing table, and then those tables are used for forwarding function. Okay, sometimes some routing tables when you also do peering with others, right? So this is BGP peer, okay? You receive and then you send out, okay? Sending out the prefix from you. So that means when you send the prefix out, you can do filter also here. Filter. Okay, so this is incoming filter, this is out filter. Okay. Can you? Yes, you can. So this is eBGP and iBGP. So if you have an AS, this is AS number, AS organization. So if the BGP is between different AS, it's called eBGP or external BGP. So inside AS number, we have several routers, for example, here, and then they connect to each other, but their AS number are the same. So it means that it's iBGP or internal BGP. So basically, that's the difference between iBGP and eBGP. Right. Yeah, so this is one example of eBGP. See, so eBGP, I mean, if they are connected to different AS number, it's just called eBGP. So by looking at the AS number, you can know, you can see it clearly as eBGP or iBGP, as simple as that. This is an example of iBGP. So this is eBGP, okay? eBGP is between, see the difference, right? Oops. See, it's between AS. So you have one AS here, another AS. So AS numbers are different. Okay, so those are eBGP. Simple as that. But here is iBGP. Okay, IBGP means internal BGP. So all of them are belong to one AS. Okay, so they have to do a mesh peering between them. So A has to do a peering to D, A to C, A to B. Okay, and then that's router A. And then router B must do a peering to A. It's already done. And then to B, and then to C. Even though it's not directly connected, okay, the peering has to be done to all of them. Okay. Okay, so everyone must do a peering to everyone. Okay, every router in the AS number. Okay. BGP on Mikrotik, yeah. Okay, so to set up a BGP on Mikrotik, it is not that hard. Okay, so basically you just define your AS number, the router ID, and then set up a BGP peer. Okay, you type a name here. Okay, okay, check the remote addresses, remote AS number. Okay, and then that's it. You have a filter here as well, but it's an advanced topic. Okay, we don't discuss it because we just only have 60 minutes. Okay, lots of parameters here, but we don't discuss them. Okay, but at least you get an idea about how BGP works. Okay, that's the purpose of this webinar. And then after that, you can display the peer. Okay, so this is how it looks like. This was taken from a live router. As you can see, we have two peers. Okay, and then we also have a peer to Kimru, and then we have a peer to OpenIXP, and these are the prefix. Okay, this was taken maybe several years ago. As you can see, the total prefix in the world is 633,945. Okay, and then here is another prefix from others, and then here is a Kimru prefix, and then this is for internal OpenIXP in Indonesia. Indonesia. Sorry, my bad writing. This is O, right? Okay. Yeah, so these are the prefixes. Okay. And then you can see the routing tables. Okay. And then we have a live practice. Yay. Look, this is the live practice topology, okay? So please take a picture. So we have 10 routers. Okay, so from router 1 to router 10, okay? So please take a note, okay? You can take a photo of this topology, okay? So these are the router number, okay? And then they connect to Ether 6, all of them to Ether 6. Okay, we have router 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have a PC here, right? PC 101, 102, 103, 104, and so on and so forth. Okay. So all of them are connected to switch 86. Okay, you cannot access the switch here. Okay, so all of them connect to Ether 6. And then this must have an IP address. Also, they must have an IP address as well. So IP address is X. So if I'm here router 1, my IP address gonna be 192.168.86.1. Okay, because my router here is router 1/24. correct? Yeah. So IP address here is .2, right? Here is .3, .4 until .10. What about the IP address here? Okay, so let's say, okay. So what if we do like it's 10.1 because this is a router 1, right? And then this is PC101. So 10.1.101 dot. Okay, this one is going to be 1. It's going to be .2, for example. So 1 and then 2. As simple as that. All right. So that's the naming, the IP addressing conventions in our topology. Yeah, hopefully you can understand that. Any questions before I generate the username and password for you guys? No one? Really? Okay, I'm creating a user now. It takes several. Oh, that's very fast. Okay, let me check again. Oh, I made a mistake. That's why it's so fast. Usually it's not like this. Okay, now it works. Okay, I have, okay, while waiting until the process is done. How to join a pairing? I have a question here. How to join pairing with a core network without subscribing to an ISP for a campus? Okay, let me check. Let me understand your questions. How to join peering with a core network without subscribing ISP? So if you don't subscribe to ISP, you're not part of the internet, right? See? So you want to access Google, but you don't want to connect to the internet. How come? Okay, let me check here. Yeah, okay. See? So you're just only one dot here, right? Okay, this is Google, right? You want to access Google. And this is you, okay? You don't want to connect to your ISP. How? You have to connect to ISP because if you want, like what I said, if you want to connect to the internet, okay, you have to be part of the internet. You have to connect to the internet. If you want to connect to them, they should be able to connect to you, right? Okay, so hopefully that answers the question. How different to configure BGP in Mikrotik as compared to Cisco? Well, I mean, for Cisco, you can just it's very simple. You go to BGP something, and then you set up AS number. It's not that hard. Okay, it's not that hard. But I can say it's also very simple to set up a BGP in Mikrotik, and then you can do it with GUI. Okay, but we will do it with the CLI. So here you just define the instance AS number. You define your own AS number that belongs to uh, to a router. So that router has to be, you have to configure your router that the router is part of a certain AS number, right? So you put the AS number here, router ID there, and then you set up a peering and done. As simple as that. Oh, okay. You can also advertise the prefix. Yeah, but I forgot to put the prefix definition here, but you get the idea. Okay, so next is just a simple one. Yes. When we had a public IP address, suddenly we get block. It will be block our ASN2. Oh, that depends. Okay, if the person can That depends. That depends on the policy of the one that blocks you. Okay, so sometimes they block the whole AS number or just your own IP address. So that depends. Okay, use some firewall products. They have a list of blacklist AS. So they just block the AS. For example, I was blocking AS number from China Telecom. Okay, you can Google it. What's the AS number of China Telecom? Why? Because their public IP address is doing DDoS to our network. Sorry, China Telecom. Yeah, for example, spamming issue, yes. And BGP VRF, yes, BGP support VRF, yes. So I want to register my campus to the internet, like ISP. How can we do that? Well, you have to apply IP addresses. Okay, you have to apply. You have to apply for a public IP address, and then you set up a BGP to your upstream, to your what is it? To your upstream ISP. Yeah. Another question here: can we make IX then IIX? IX means Internet Exchange. IIX means Indonesia Internet Exchange. Yes, you can do it yourself, and then we already have several IX here in Indonesia. Mostly in the big cities, Medan, Pekanbaru, Jakarta, Bandung, Surabaya. Yeah, they have a local IX. And then the reason you set up a local IX is because that's the place where AS number are met. Usually you put your own server there. What else? Can we combine IX then IX to failover? You mean you have a dual incoming ISP? Yes, yes. Yeah, yeah, sure, sure. You can. So you have, so this is very common. Okay. Okay, I answer a lot of questions like this about load balancing. Okay, so I have a border router. Okay, I have ISP1, ISP2. Okay, you connect here, you connect here. Okay, so make sure it's a BGP. Okay, it's not a BGP. Okay, and then this is your host, right? Blah, 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 blah. Yes, you can. So if this one down, and then everyone can go here. Yeah, yeah, no problem. Okay, that answers, hopefully that answer questions. Okay, so what's that mean, route reflect? Oh, okay. It's a good question. So route reflect. So as you can see, for internal BGP, we have to do peering to all of them. Okay, so for example, okay, let me, okay, I'll stick with green. Stick with green color. Okay, so as you can see, A has to do a peering with D, with B, with C. Okay, so everyone must do a peering to everyone. Okay, yeah. So with route reflector, it means that you set up a router that is function as a hub. Okay, so for example, as a router C here. Okay, so we don't need to do a peering here. So no peering, no peering. So everyone can do peering to router C. So it's like a concentrator of a router. Okay, so that's the meaning of route reflector. If you do, okay, I have another question here. If we do peering with ISP, I want to subscribe to other ISP for backup. Yes. Is it possible to a number? Oh, What's your question here? It's difficult to understand. Is it possible that two S number, or that two AS number are known to the internet using the same AS number? Hmm. Okay, let me digest the questions. Okay, let's draw a. Okay, do we want to have a live practice here or not? Okay. Oh, okay. Maybe this one can be an example. Okay, so you can see. Oh yeah, I just realized that we can do this exercise as load balancing. So as you can see, maybe this is IS. Uh, um, looks like we can use this ISP1. Okay, this one ISP number 2. Right. Yeah. So they're connected to the same switches. Okay. So either you have a two options. You go to here, right, or you go to here. Okay. Same network but different gateway. So this must be a dot 85, right? Because this one is router 85. The IP address here is dot 86. Right, guys. So let's continue to preparations. I will give you the details so that you can log in. Oops. Oh. Okay, I'll paste the 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 connection to the SSH details to group chat. Okay. Oh, it's already 8:30. Oh, okay. Oh, sorry, guys. Yeah. Oh, we have a good discussion here. Okay. Maybe we can extend up to 15 minutes. Okay. Just want to show you how to log in. Make sure you can log in, right? Okay. Let me show you my terminal here. Okay, we just extend 15 minutes. Okay. Yeah, because it's okay. Time flies very fast. I thought it's just 8:15. Now we're already late. Okay, that's fine. Okay, as you can see, I already log in to. I will share my screen here at the full desktop. Okay, can you see my screen? Okay, so I already log into to live practice server. Okay, so I can see some of you already log in there. Okay, that's good. So next is we try to log into our routers here. So how to do that? By using telnet. So I do telnet net sim 117.117.lan.glc networks.com. Okay, and then the port. Okay, port 00X. So X means your router number. Okay, so if you want to go to router 1, change X to this into 1. Okay, I log into router 1 and then here I go. So I connected directly to router 1 using their console windows. I can see somebody also playing with router 1. Okay. No password. Okay. So if you log in also to router 1, you can see what I'm typing. Okay. So please do not do something nasty here. Okay. Oh no. Okay, I will try to connect to other routers, to router 2, for example. Okay, so I log in admin. Okay, so this one is okay. And then what else? Okay, so I can see /routing BGP print. Oh, sorry, routing BGP instance print. Okay, it's still 0. I mean, still on default settings. So what I will do here, because for example, I can use here the AS is AS2. Okay, and then router ID, for example, 10002. Okay, 1000X. That's the time. Okay, so what you can do is /routing BGP instance set. Okay, set number default. AS is AS number 2. Router ID. Sorry. Sorry, I have to mute. I have to mute your microphone. Okay. 10002. Yeah. Okay, that's your AS instance. Okay. And then what else? You need to set up IP addresses, right? Okay, so this we already have an IP address on Ether 1, but you need to set up an IP address on Ether 6 because here, when you want, so the objective here, you want to connect to router 86. Okay, so that means you need to have an IP address on Ether 6, address 192.168.86.2/24 on interface Ether 6. Yes, /IP address print. Okay, I have the IP address now. And then I can ping 192.168.86.86. Yes, done. Okay, so I will set up a peering /routing BGP peer at, okay, remote AS is, this one is AS86, okay, AS86, remote address 192.168.86.86. Done. Okay, so, and then we can check the status. /routing BGP print peer print detail. So you can see status here. Yeah, is nothing. Okay. Okay, so okay, I will connect to the other routers. Okay, control brackets, square brackets, and then Q, and then I can log into router 86. Okay, I'm at router 86 now. I set up the same thing, routing. Slash routing. Oops. Yeah, it's quite slow here. Routing BGP instance set. Okay, so number is default numbers with S. Yeah, the good thing for Mikrotik is when you do when you wrongly type the command, the color will turn to red. So it's unlike Cisco. Numbers is default. Okay, connection here is quite slow. And then AS is 86. Yeah, it takes time. So guys, set numbers default. Now it's fast. AS number is 86. Router ID 10.0.0.86. Yeah. And then after that, you add a peering to router 2. Peer at remote address 192.168.86.2. Okay, remote AS is 2. Okay, and then you check the BGP peer print and then detail. As you can see, the status here is already established. Yeah. KE mean established. So as simple as that. So at this moment, I already set up a BGP peering between router 2 and router 86. Okay, so I already set up a BGP connectivity from this router to this router. Right. Okay. Okay. Let me answer questions. Oh, lots of them. As easy, you can have 2 or 3 connection. Yes, that's correct. And then load balancing. How many AS number we can configure on Mikrotik routers? Only one. Yes. Yeah, I mean one physical router. Okay. One physical router, because it belongs to one AS number, right? And then you connect to different AS number. Okay, so I got message from admin here. Okay, saying that we are running out of time. Can I have this recording and slide? Yes, we will upload it to our YouTube channel. And then, okay, is there any slides after this? Q&A, yes, we already have a Q&A. So if you are interested, please come to our training. we will learn more about the BGP. We have a BGP workshop in the future. I'm not sure, maybe you can ask admin. Here's the syllabus. We have a 16-hour workshop discussing the BGP. So it's much more detailed discussions. And then these are the syllabus. We'll be talking about the autonomous system review, BGP filter, BGP attribute, multi-hop peering, next hop attributes. Oh, I type it twice. Yeah, attributes like weight, local preference, prepend, messages, loopback interface. We combine between BGP and IGP like OSPF or RIP. So before you go to BGP, this BGP workshop, make sure that you already understand how routing works, and at least you already configure OSPF or RIP, and then make sure that you understand how they works. Okay, because BGP will be working hand to hand with them. Okay, and then BGP soft configuration, regex, regular expression on BGP filter. BGP authentication, we talk about private AS, similar to IP address, private IP address. We have public IP address, we have private IP address. Same with similar to AS. Sorry, and then we have also mesh peering and then confederation and route reflector. Right, so thank you very much for coming, and please do not forget to submit your feedback. Okay, so we are quite late today. Really sorry about that, because I can see so many people are interested with the topics. All right. For those who are able to log in and then configure your router, thank you very much. Congratulations. If not, and then yeah, we can do it next time. Okay, so end of the slides. Thank you very much for your attention. Again, please submit your feedback. Yes, admin, go ahead.
Sorry, for the last request, can you turn on your video? Then we can take picture together.
Oh, yeah. Okay, so guys, please turn on your camera. Okay, make sure your face is there, not somebody else. Okay. Okay, turn on, and then we want to make a group photo as a proof that you're already here.
Hi.
Hello, guys. Okay, so we have 61 participants here. Please, if you have a camera, please turn it on. And then we'll take the pictures. Okay, a group pictures. Okay, do not be shy. Come on. Right, okay, let's take a picture. 1, 2, and 3. Okay, one more. Oh, okay, more coming. 1, 2, 3. Yeah. Okay, so we just only have how many? 16. Okay, but we only have 61. Oh no, many are shy. Okay, never mind. Again, thank you very much. You can turn off your camera. Okay, next time we'll do a webinar with different topics. Right, guys. Again, anything else from admin?
Nothing, just we share about information. Please put your feedback, because really this is really useful for us for next. Yeah. And then if you want to know about us, so you can search in our website also. I've been put in group chat as well for schedule. Yeah, so see you on the next webinar, and thank you very much for coming. Oh, person from Philippines, Malaysia, Myanmar, so what else? Papua New Guinea, and then Nigeria, Bulgaria, and what else? Of course, Indonesia, yeah. So thank you very much for your attendance and much appreciated.
Yeah. Right. Thank you very much, guys. Hope you enjoy the webinar, and then see you next time. Goodbye.
Don't forget
Mm.
feedback, please.